For today, we're going to run this whole show. We're going to actually start running simulations. Just as a quick overview, simulation is basically mimicking real world. So we know we can't actually grab, let's say we want to simulate a poker game. How often can you have 2 of a kind or 4 of a kind? Well, if you don't have cards with you, how are you going to simulate that? Well, we can start running numbers, assign these to numbers of probability, and run tests through that. The trial is each time we run our simulation, and at the end we get our response variable. That is our results. And a component is our steps in building the simulation. So let's look at one of these here. We're pretty sure that your candidate for class president has about 55% of the votes in the entire school. Maybe we could change this to prom king or prom queen. But you're aware that only 100 students will show up to vote. How often will the underdog win that has 45% of the support? To find out, you need to set your simulation. So we're only going to look at 100 students, but that doesn't mean that it's going to be evenly distributed. What if only these 45% make up 60% of these hundreds? See what I'm saying? This isn't going to grab exactly the 55 and the 45 of the entire school. It may grab majority of these. It may grab majority of these. We don't know. We're going to run a simulation to find out. So how would you describe how you would come up with the components here? Remember the 0 to 1 represents, or 0 represents 0 eggs, 1 to 2 represents 1 egg, 3 to 4. How are we going to set this up? So tell me, how would you run this in regards to like a number generator? If we get numbers between 1 and 45, what? Yeah, our underdog. And if we get numbers between what? What's going to be our majority? Between what numbers? 46 to 100. So we're going to run random numbers that are going to generate. If I get 38, underdog got to vote. So our simulation is going to run. We're going to have a random number generator. If we get numbers between 1 and 45, those are considered the underdog votes. 46 to 100, the majority. So how would we simulate the trial? We'll just run that generator, right? Describe the response variable. How will we decide who wins that round or that one particular trial? So we're making tallies. 1, 1, 1, 1. How do you figure out who wins? Who has what? The most votes. How many votes does it take to have the majority? 51. Very good. Out of 100 students, 51. So describe the response variable. The winner. First to 51 votes. Doesn't make sense to keep on running 100 times if what, right? Once we get to 51, we're done. We know they won. So we're actually going to run this and see your results. A person with type O positive blood can retrieve blood only from other type O donors. About 44% of the U.S. population has type O blood. At a blood drive, how many potential donors do you expect to examine in order to get 3 units of type O blood? So how many times do we have to run this to get 3 people? First, our component. We're going to run a random number generator. How should I set up my values? Between what numbers is going to give me O blood? 1 to 44. And so what values will give me other blood? 45 to 100. Okay, and we're just looking for 3. So we'll start with our first trial. So trial number 1, and we'll just do 3 trials. So to run our number generator on the calculator. We go to math, over to probability, number 5, random integer. Our lower is 1 to 100. We'll say 10, because we'll get 10 numbers and see how it works. And go. So first number is 22. What was 22? O blood. So let me, 1 for O blood. Next number is 10. What type of blood is that? O blood. Yeah, 10. The next number I got was 37. What type of blood? Oh, hey, it only took us 3 people. Okay, we're done. Next, let's try trial 2. So another 6. So at least, as far as our trials, again, you would probably not stop at 3. It would take 6 people to come in for us to get 3 O bloods. Now, on average, how many people would come in? 3. So on average, about 5 people. That is what's going to be our results. On average, about 5 people. So our question was, how many potential donors do you expect to examine in order to get 3 units of blood? On average, about 5 people. So notice 1, 2, 3 took 3 people. This is my response variable. This took 6. So my response variable for this trial is 6. Likewise for this one. So this is what I mean by response variable. This is what I mean by trial. Setting this whole thing up is our component. And the whole thing together is a simulation. Let's do one more. You are playing a game in which the number of spaces you get to move is determined by the roll of a dice. Our dice are 6-sided dice, so you're going to get 1 through 6. So note we're rolling 2 dice at the same time. You must land exactly on the final space in order to win. If you are 7 spaces away, how many turns might it take you to win? To roll 2 dice, the probability of getting a 7 is what? We'll just round that up to 17%. Okay, we'll just round that to 17%. If I had asked 10, we would just say 8%. So 17% chance of getting a 7. 17% chance to roll a 7. So what numbers am I going to use? Notice this last problem, 44% chance. My numbers were 1 to 44. 17% chance my numbers are 1 to 17. And then all others is going to represent what numbers? 18 to 100. Yep. Trial number 1. How many rolls does it take me to get a 7? Now, I'm not going to use a random number generator because there's actually a site that rolls dice for you. Classroom screen. And let's go. 5, 6, 7, 8. So that's 1. 2. That's a 4. 4, 5, 6. 3. Hey, took 4 tries. So on trial 1, our response variable was 4 tries. So you would say it takes at least how many tries to roll a 7? 4. And you would say on average it took you how many tries? It takes me roughly 2.5 tries, 2.4. About 2 tries to roll a 7.